everybody, I'm Mr. Loy, your friendly D&T teacher. In this teaser video, you can see that I have a typical AA 1.5 battery cell and a very strong neodymium magnet below and a piece of bare wire coiled in this manner. I'm performing a little experiment to investigate whether the homopolar motor actually works. So you can see that yeah, it's actually kind of like spinning by itself. Of course, I got to nudge it a little bit because of the contacts below, you know, from the positive terminal, all right, the anode of the battery, and then the current flows down this wire to the bottom when the other end of the wire is in contact with the magnet. So you can see that actually it works, okay? It's just that the coiling is not done very smoothly, and therefore this wire did not spin non-stop, okay, or until the chemical energy in the cell runs flat. So this is a very simple experiment to demonstrate some understanding of basic electricity and some physics law. For D&T, basically our focus is more on use of electronics components. Of course, in this case, this is an output device, and this is a slow blinking LED, which you can see here. Actually, it's fast blinking. And what we have is instead of a bulky AA, we have what we call the button cell, all right, which can be actually housed in this flat battery holder here. Now, coming to the focus on electronics, let me just plug in the power supply, all right, and of course, how do I know whether it is connected properly? You can see that I have a little yellow LED over here. Now, this breadboard or prototyping board has quite a number of circuitries involved here. So for example, you can see that this is a momentary switch. It's actually a press once, okay, or you push and release button, which we call it. And of course, the current flows from this short red wire through the switch if it's closed, through the fixed value resistor, to the positive, the longer leg of the LED, and then of course to the shorter leg of the LED, and the current flows back to the 9-volt power supply, okay? So this circuitry works here. Now, of course, to understand certain switches, okay, let me just unplug this end of the yellow wire, and then just let me connect directly to this end of the wire, okay. So apparently it doesn't really light up, okay. So that's a negative demonstration. Now sometimes you have to check whether there's current flowing, all right. So just now I noticed that there's no current flowing. What I wanted to demonstrate is the direct connection, okay, the understanding of the switch here. You can see, just now I press, this one lights up, but how is it that this yellow LED is continuously light up with this green wire connected to one end of the switch over there? Because you have to understand how the inner workings of this switch is. So this is actually a direct connection. So without the need to press the button, there's current already flowing and light up the yellow LED instead. So let's move on to the light dependent resistor, which you can see actually is over here, all right. So you can observe that the yellow LED is light up, okay, and this is a brightly lit room. You can see that if I cover the LDR, all right, lesser light will shine onto the LDR, and therefore the yellow LED dims, okay. So you can see. So in the introductory video, I mentioned briefly about the property of the LDR is inversely proportional relationship between the intensity of light and the amount of resistance, okay, the value inside. Now moving on to this other side here, you can see that I have what we call a potentiometer and a buzzer, all right. Buzzer is another output device. So if I were to tune this, you can hear something, right? Okay, maybe the battery. Okay, that's pretty loud. And I tweak a little bit. You can hear that the sound varies, all right, to very loud to less loud. So less loud means there's more resistance, lesser current passes through the buzzer. But if it's very loud, what it means is the variable resistor that I actually adjusted here, lesser resistance, so more current will flow through, and therefore the buzzer actually sounds even louder. Okay, so I have actually introduced a couple of input devices, all right, mainly the momentary switch here, the LDR. Okay, I also introduced you the output device such as the LED and the buzzer, and one of the simpler process component here which we call is the variable resistor. Now variable resistor is actually a potentiometer as well, because there are three contacts. If three contacts are used, it actually divides the potential difference in a circuit. But if only two contacts are used, basically you use it as a variable resistor. Okay, so the same component can be used for two different functions. Now this teaser video ends here.